10, 9, 8. Ignition sequence start. Engines armed. 5, 4, 3, 2, 1. All engines running. Launch command.
Hey there everyone! In the last video we got an introduction on the life cycle of stars and we discussed about the complete life cycle of a low mass star. So now welcome to part 2 where we discuss about the life cycle of high mass stars. And the life cycle of high mass stars is actually very special since it is also the kind of star which leads to the formation of a black hole. So let's get straight into it. Now, before starting, let us figure out what a high mass star actually is. So we can already get a rough idea of what it is. A star with a relatively higher mass. But what exactly is it by definition? So a high mass star will have a mass that is greater than 8 times the mass of the Sun. So now I will be telling you a small recapitulation of what we had started off with in the last video. So in the last video we learned that the life cycle of any star will always start with a body called a stellar nebula, which is kind of like a cloud of dust and gas. Now all the stages of the life cycle after the stellar nebula will be divided into two branches. One branch is of low mass stars and in the other branch the stellar nebula can turn into a high mass star. And in this video we will be discussing about the stages in the branch of high mass stars. So the life cycle of a high mass star, as we discussed earlier, starts with a stellar nebula. Then it turns into a massive star. After the massive star stage, it will turn into a red supergiant. Then there will be a supernova explosion that takes place. And from the explosion, two bodies can be formed, either a black hole or a neutron star. Now here we can see a stellar nebula, which is basically just a cloud of dust and gases like hydrogen and helium in space. Now obviously, like every other celestial body, the nebula will also have gravity which pulls things towards it. But this gravity started to pull all the dust and gases towards the center and made the stellar nebula collapse in on itself. So after this collapse took place, the dust, hydrogen and helium got packed into a really dense and hot ball at the center, which is somewhat like a ball of fire called as a protostar. Now, inside the core of the protostar, the particles of hydrogen started colliding into each other, and these collisions produced heat, which ended up combining the two particles of hydrogen into a particle of helium through a process called nuclear fusion. Now the helium formed at the core from nuclear fusion exerts an outward force going away from the core and pushing on the outer shell layer of the star. And obviously there is also the star's gravity, which is trying to compress the star in on itself. Now the opposing forces of gravity and nuclear fusion, when they are almost equal, they make the star stable. This is called as a main sequence star, and for the branch of high mass stars it is called as a massive star. Now you might have noticed that unlike other stars, the massive star is blue in color. Meanwhile, other stars are almost yellow, orange or red. Well, you might not know this, but heat actually has colors. Like we see orange flames and sometimes we see blue flames, which are different temperatures and have different colors. Now, if a flame or a star is almost red in color, it is on the coldest level. Then we have the colors of orange or yellow, which have average heat for stars. And the hottest colors, meaning the stars which are burning the hottest, are in the colors of white or blue. So, red giants or red supergiants, which are glowing dimmer and have less nuclear fusion, glow red as they are colder. Average stars are in the middle zone, and the hottest stars, like white dwarfs, massive stars, and neutron stars, are in the blue zone. And a massive star is this hot because it has more matter, making it more denser and hotter. Now, over time, the nuclear fuel and hydrogen at the core will get exhausted and it will do much less nuclear fusion. Meanwhile, the outer shell of the star still has hydrogen left in it and it will continue to exert an outward force from nuclear fusion, making it expand outwards. But the core of the star, where no more nuclear fusion is taking place, the gravity will take over and the core will start contracting and collapsing in on itself. So this forms a larger star called as a red supergiant star, which glows dimmer on the heat scale and is much less hotter because there is less nuclear fusion happening at the core. Now, eventually, the gravity will completely take over at the core of the star and it will collapse in on itself, creating a huge explosion called as a supernova. Now, the shockwaves from this explosion are so huge that they completely blow away the outer shell of the star consisting of the gases and dust. So, this creates a cloud of dust and gas around where the star used to be, called as a supernova remnant. So, the core of the star before it collapsed consisted of electrons and protons. And when the core collapses, then all these electrons and protons also get crushed at the point where the core collapsed. So these electrons and protons, when the core collapses, all get crunched into neutrons, creating a neutron star, which is again very, very dense and hot, which is one of the reasons why it glows white or light blue. Now, one more possibility for when the core of the star collapses is that all the matter gets packed into a really, really tiny point which has literally zero size, like no size at all. And this will have infinite density and it is called as a singularity. Now, due to the singularity having infinite density, it also has really, really, and I mean so insanely huge gravity. So, the singularity is what is believed to be at the center of a black hole. Now, let us look at the anatomy of a black hole. As you can see, at the center lies a singularity, and the whole black sphere which you see is the event horizon. Now, if an object reaches the event horizon, no matter what, it cannot escape the black hole's gravity, which is why it appears black, since not even light can escape the event horizon. And the white glowing stuff which you see around the black hole is a disk of burning gas and dust called as an accretion disk.